Hello, students, and welcome to this episode of Calculus in 10 Minutes or Less. Today, we are going to review the chain rule. The chain rule is stated here, and remember that the chain rule relies on identifying the function composition, if you're given one, in a problem. You may find this rule stated in section 3.6 of OpenStax Calculus Volume 1. Here, we're going to review the example from that same section, example 3.48. It is given below, and it is stated as using the chain rule and the power rules. Now, what you notice here actually is a quotient, and you might be inclined to say, okay, I'm going to do a quotient rule. The secret is you can do a quotient rule and still get the same answer for this problem. But I don't know about you, I like to try to avoid the quotient rule because I tend to make errors when I apply the quotient rule. I prefer finding derivatives using the chain rule if that's an option. So in this case, it is going to require us to rewrite h of x as the following expression, remembering the exponent rule. If you have a negative exponent, then that is equivalent to moving that base to the denominator of a fraction and then changing the sign of the exponent to be positive. But this rule works in reverse as well. Here we have a positive exponent in the denominator of a fraction. So we can move this expression to the numerator, right? Because it's almost like there's a 1 in the denominator there. And then take the exponent and turn it negative. And then hopefully you see that this is a chain rule problem because the 3x squared plus 1 is now being operated on by the negative 2 exponent. So in this case, to find h prime of x, we will differentiate that expression. I like to identify the inner function first. This is my personal preference. A lot of texts encourage you to start from the outside and work your way in. I personally prefer to start from the inside and work my way out because once I see that expression in green being operated on by an external expression, for me, it's a little bit easier to identify g of x first and then pretend like I'm marking it out. And where I mark it out, I'm going to put the variable x in my f of x expression. That helps me remember it personally. It helps me learn how to use it a little bit quicker too. Of course, speed is not as important here as accuracy, but if that helps you as well, use it. Then we write down our subsequent derivatives. Negative 2, x to the negative 3 is the derivative of x to the negative 2. Remember the power rule here? We bring the negative 2 down out in front, and then we subtract 1 from the derivative, or from the exponent, forgive me. Minus 2 minus 1 is negative 3. And then we're going to go ahead and differentiate g. The derivative of g is 6x. Please go back and review the power rule if you find yourself really confused about what I just wrote down. You're not using your time efficiently if you don't understand the power rule very well at this point and you're trying to learn the chain rule. And this is why this example says using the chain and power rules, because this is a power. Inside that power is an expression, 3x squared plus 1. So we have a composition of the functions 3x squared plus 1 and negative 2. Then write down your rule. I'm going to copy and paste it because I can, and I'm trying 90 minutes or less. But I encourage you to rewrite it every single time. As you do, you will become much more efficient using this rule. We call this an aside. Okay, this is scratch work, kind of. You can put this on another piece of paper if you feel so inclined. But for me, I'm going to then continue my rule, the chain rule below, and carefully picking up each expression that I need. Recognize too that the f function that you assigned is not going to be written in our chain rule. In fact, we are going to have f prime evaluated at the green function, and then that's going to be multiplied by the orange function. Another way to write this that may be helpful to you if this notation bothers you is as follows. So this is an equivalent expression. You could also write this as negative 2 times g of x times g prime of x. Sorry, negative 2 times g of x, the green function, to the negative third. Notice that I'm picking up this f prime and pasting it right there, but then I'm indicating that since I want to find f prime at g, I have to put the g function in for all of the x's in the purple f prime function. Either way you do this will lead to the same result. So both of these things are going to lead us to see negative 2 times 3x squared plus 1 raised to the negative third power multiplied by the orange 6x. Now, best practice here would be to write this as negative 2 over 3x squared plus 1 to the third. Now, I've applied this exponent rule again. Now I have a negative exponent. I'm going to move that term to the denominator and make the exponent positive. But then I also need to multiply the 6x. So the best final answer would be negative 2 times 6, negative 12x, divided by the expression 3x squared plus 1 cubed. And again, I encourage you as Calculus 1 students to leave denominators as is. Only simplify them if you're absolutely certain in a moment as you work through this algebra that you absolutely need to.